All right, we're back. We are still on page 15. We just completed this table, which you are going to memorize. You're going to know it backwards, forwards, upside down, switch some rows, switch some columns, radians, degrees, everything, right? You have to know it. You're going to use it so much. It's an investment. It's not going to take much time to memorize it. And once you do, you're just going to find yourself using it all the time. So well worth it. Let's talk now. So we have sine, cosine, and tangent. Those are all well and good. It turns out that there are three more trig functions that frequently come up. They're very related to the functions you already know. These are going to be called reciprocal functions. So they're reciprocal functions. They are not inverse functions. So what's a little confusing is the following. And I don't really have any room for it, so that's great. I'm going to do it down here. Okay, so sine to the negative first isn't sine to the negative first of x, is inverse sine, not the reciprocal of sine. So if you think about it, sine is opposite over hypotenuse, right? Sine is opposite over hypotenuse. The reciprocal of sine should be hypotenuse over opposite. That's what it should be. Take the reciprocal, flip it over. So this is what we're talking about. We're talking about flipping our ratios. We are not talking about going from, you do the trig function of an angle, you get a ratio. You do the inverse trig function of a ratio, it gives you an angle. You do a reciprocal function of an angle, it gives you a ratio. So these are things that take angles as arguments and give ratios back. Now, it's kind of weird that you would even need these. You, in fact, don't need them, but they do exist, and you're going to see them all over the place. I mean, you need them in the sense that, like, you're not going to survive this course if you don't know them. But, like, could you potentially have gone through life never knowing them? Maybe, I guess. All right, so here they are. So we have cosecant, secant, and cotangent. And I've written them in a very weird order, in my opinion, sort of. I've written first secant. So you will notice that secant is 1 over cosine. So if cosine, nobody really thinks this way in my opinion. I don't know. Like if someone tells me to find the secant of something, what I do is I find the cosine and I flip it over. So if I find the cosine and it's like 3/5, I automatically know the secant is 5/3 to flip it over. But secant goes with cosine. And now, so the next one is cosecant goes with sine. People always want like the two S's to go together and the two C's. Doesn't work that way, right? Secant is 1 over cosine, which means it's hypotenuse over adjacent. Cosecant is 1 over sine. It's the reciprocal of sine, which means it's hypotenuse over opposite, right? So if someone says find the cosecant of something, I basically find the sine of that angle, and then I take its reciprocal. I don't really think of cosecant as hypotenuse over opposite, even though it totally is, and I'm aware of that. That's not really how I think it through. And then cotangent is the reciprocal of tangent. So if tangent is opposite over adjacent, then cotangent is adjacent over opposite. I actually do sometimes think of them this way, but more like in calculus than in this course. But like, you're going to know them anyway. So these are our reciprocal functions: secant, cosecant, cotangent. The reciprocals of secant goes with cosine, cosecant goes with sine. Cotangent nicely does go with tangent. So here's a thing that we can do. Let's pretend that our calculator is broken. I like problems like this. We're going to pretend our calculator is broken, or potentially that you have a calculator that doesn't have these built in. Their older calculators don't have the reciprocal functions, but older textbooks do, and you would have to evaluate them, so you'd have to like figure out what to do. So here's what we can do. If a problem says, figure out cosecant of 37.8. Well, I know that cosecant is the reciprocal of sine. So I know that the cosecant of 37.8 degrees is 1 over the sine of 37.8 degrees. And I'm going to use a calculator in a second to get that. First, let's do this. So let me warn you. What color? I would love to warn you in like the the most dangerous color of all. All right, let's do this. Never take the reciprocal of an angle. I can't think of a RECIP. I can't think of a single time you would ever take the reciprocal of an angle. I mean, like, why would you do that? So what color can I highlight this in to make it really offensive? This is not offensive enough. I want this to look horrible because that's what it would be. Well, now it looks horrible. Man, if you don't highlight all in one shot, it's so annoying. Come up with a scenario where it makes sense to take the reciprocal of an angle. Oh, a 90-degree angle. How about a 1/90-degree angle? Like, why would you care about that? You are going to flip ratios. Cosecant is a ratio. It's hypotenuse over opposite, right? I can flip that over, right? I can flip over opposite over hypotenuse. I could flip over opposite over adjacent. Those are all ratios. Makes sense to flip them over. Secant is a ratio. Makes sense to flip over secant. So secant of 48.2 degrees is going to be 1 over the cosine of 48.2 degrees. And that's that, right? So we can use a calculator, but that's as good as we're going to get. Cotan, so this one's weird because, like, I don't know why I decided to do 444.25. It doesn't make a difference. The cotan or cotangent of 444.25 degrees is 1 over the tangent of 444.25 degrees. So we never flip over an angle. You just do, it's not done. You just don't do it. So now what I'm gonna do is switch over to the calculator and see if we can get the calculator to give us some answers. Let's see. All right, here we go. So I am in degree mode, which is good because that's what I need to be in. And I wanna find the, so here, let's try this. So let's use the trig button. Let's just find out the cosecant. Cosecant of 37.8 degrees is that. Okay, let's check and see if what we wrote by hand is right. So fraction template 1 over, and we'll do the sine of 37.8. Same result. So this is something you can do. This is something you should do. You should check your answers. So instead of pressing the trig button, I'm just gonna type them in. Secant of 48.2. Okay, then I want to try 1 over the cosine of 48.2. What if you accidentally did cosine of 48.2 first, right? So one option is, you do this, and then you just go to the negative first. And there you go, right? So, like, you don't have to put it in correctly the first time. You should, but if you don't, you can save it. Cotan of 444.25, okay? Now, let's do 1 over the tangent of 444.25. Perfect. Well, 444.25 is bigger than 360, so let's find the principal coterminal angle. So there's two ways I could do that. I could just subtract, which I think is actually the easiest way. Just subtract 360 and get this. I also could have done 444.25 divided by 360, which gives me 1 point something. 444.25 minus 1 times 360. So this is like the long way to get to the same result. But either way, so what if I do 1 over the tangent of 84.25? I get the same result. So it's already like off the screen. So you get this. Another thing you can do if you're not really interested in the value, you could say like, how about cosine of 53.2 equals, so cosine, if secant is the reciprocal of cosine, cosine should be the reciprocal of secant, so it should be 1 over the secant of 53.2. And why am I getting false? You know what, let's do, I think that, I know that is not false. This is a rounding error. That was not, that like ruined the whole thing for me. Here, let's do this. Cosine of, see, I don't know if I can come up with any of them that are going to work. Let's see. 1 over the secant of 60. True. Yay. Okay. Let's look at this one that it said was wrong. So cosine of 53.2. Oh, wait, there's already a decimal. Oh, you can't put 2 decimals. Okay, 1 over the secant of 53.2. Suspicious. Now, where's the problem coming from? Let's do this. So the problem is a matter of rounding, which happens a lot with division, because you're basically doing 1 divided by a crazy long decimal. Calculator's got to round at some point. So it's kind of correctly saying false because the decimal approximations aren't equal. It would be nice, though, if the calculator knew that those should definitely be equal. They should definitely be equal. So I apologize on behalf of the calculator that it didn't pop up the exact same thing. Can I do this? Can I say that the cosine of x equals 1 over the secant of x? True. Conditionally. What's it going to say? It's going to say something about domains. Domain of the result might be larger than domain of the input. That's something we will have to worry about as we go forward. We don't need to worry about it right now. So what I'm going to do is I'm going to go back to the calculator, to the notes page rather, and show it to you one more time. Then I will stop this video here and come back in the next one and do some more. So play around with these, like on your calculator. That's all you got to do. Go in there, type in a thing, type in 1 over a thing, see if you're right. It'll check it for you. So a lot of opportunities for you to practice and get really good at these on your own. You don't need someone to make up problems for you. Just do it. Just pick any number. They literally work for virtually any number. There are a few exclusions, but you probably won't stumble upon them. So, good luck. I will see you in the next video.